In this exercise, we start with the vector space R3, and then we consider the subset W, which is all the triplets A, B, C, such that A plus B plus C is 0. And we have to see if this subset is a subspace. Let's first of all get a feel for what W is. So, for example, if I had the vector 1, 1, minus 2, that would belong to W, because if I add the three components, 1 and 1 and minus 2, it is indeed 0. Another example would be, say, 0, 4, minus 4. That would also belong to W, because these add up to 0. Okay, now let's get started. There are three things to prove for a subspace. The first condition is that the 0 vector has to belong to W, but the 0 vector is just the vector 0, 0, 0. And is this in W? Well, yes, because if we look at the A plus B plus C here, it's 0 plus 0 plus 0, which is 0 as required. So the 0 vector is in W. The second condition is sometimes called closure under scalar multiplication. And what it means is that if we know that some vector u is in W, then we need for all scalar multiples of it to also be in W. So let's check if this is so always. So let's say that the components of u are some A, B, C. Then Ku is just this vector, Ka, Kb, Kc, because that's how we do scalar multiplication. We do it component-wise. Now, to say that u belongs to W is the same thing as saying that A plus B plus C is 0.